What is SDN nga ba? Now, SDN, this is an approach to networking that uses software-based controllers or APIs, application programming interfaces, to communicate with underlying hardware infrastructure and direct traffic on a network. Now, comparing what SDN is versus to say a traditional architecture or a traditional means of networking. And by networking here, I'm pertaining to the transport layer of our communications architecture. SDN is a means for us to have a centralized means of implementing configuration, performance, and control across all of the different transport elements. Now, these transport elements come in the form of your switches. Okay, comparing traditional networking, normally, you can say that logically a switch can be split into its two key components, which is the control plane, and the data plane. Now, for those who are not yet aware on what the control plane is about, the control plane, this is the logical part of your transport device responsible for um, configuration, fault management, resource management. Essentially, the running configurations in your switches is found in this plane. Okay. Now, the data plane is where the packets are being processed. Okay. So remember that in your switches, you have or it is responsible for up to layer 2 processing. So in layer 2, ito yung OSI layer natin. And essentially, this is where the user data is being worked on and being forwarded. Okay, so if I were to simplify it there. Now, traditionally, and by traditional here, I mean that how we normally go about routing and packet forwarding is that the functionalities of control and data are isolated on a device perspective. In other words, both control and data are represented across the different devices. Now, it has its own advantages and disadvantages, but focusing really more on the limitations of this setup that we have, you may have noticed that whenever we want to do configuration, i.e. say we want to already configure a specific route to our given network, we have to rely on protocols, and that protocols would be responsible to propagate the needed information, the control part of that switch, across its adjacent elements, or across its adjacent elements and adjacent interconnections. Bale, if I were to simplify that even further, we rely on protocols to ensure that communication is consistent across the entire network topology. Okay. Now, the limitation there is that on a given scenario, what if, say, I configure a specific protocol on one switch, and then just by sheer human error, I forgot to configure the protocol needed for its adjacent switch. So what would happen? Of course, the packet would not process anymore. Kasi you have to ensure on having the control plane converged and consistent across all of the interconnected elements in your topology. Okay, I mean, it happens sometimes that you often miss a certain configuration in one network element, and then when you try now to troubleshoot, you see that packets are not being forwarded to the destination device. Okay, probably because of human error. So that is one scenario for it. Now, SDN promises to solve one of these issues by already centralizing the control aspect of it. So you now implement one device known as the SDN controller, wherein all of the configurations, alarms, and performance management of all of your elements are already found in that one central logical device. Okay? This process is a move away from the traditional network architecture in which individual network devices make traffic decisions based on their configured routing tables. Okay? Now, the architecture in itself, moves the control plane that determines where to send traffic to software and leaves the data plane that actually forwards the traffic in the hardware. Kaya din siya tinawag na software-defined networking. It's because the network, the software-defined aspect there is the configuration or specifically the control plane. No? Dati kasi, these configurations are embedded literally into the hardware part. But through the use of a controller, we can now implement it, although technically it is still software, no, even traditionally itself. The purpose of having an SDN architecture is having a single plane of glass instead of having several device by device basis perspectives. Okay? Now, an architecture, so generally speaking, the SDN architecture consists of 3 layers, okay? And these layers are stacked on top of each other. So first off, you have the infrastructure layer. So this layer is where your switches are located, okay? This is where your forwarders are also located. Now, on top of your infrastructure layer, you have now your control layer. This is the centralized control. And this is also where the SDN controller, aptly named so, is also located. And finally, on top of your control layer, you have your application layer. The application layer, this is where all other level 7 applications would be residing, such as your load balancers, your firewalls, your policies, are placed. Okay. These 3 layers are then interconnected through a series of application programming interfaces or APIs. Okay. Now, notice that in this diagram that I was able to get, where does OpenFlow here reside? It actually resides in the southbound layer between the controller and the forwarding switches. Okay. More of this one later on in the succeeding slides. Now, comparing first traditional networking or the usual IP-based networking that we have versus SDN, you'll notice that the SDN or the software part, the software component here, primarily relies on the implementation of a controller. To put it bluntly, in the SDN environment, you're essentially having your switches become, to lack of a better word, dumb forwarders. Okay? I say here I use the term dumb forwarders here is because the configurations are no longer being done on the device anymore, at least at least manually. You now depend on the SDN controller to do all of the configurations, and it is now up to the SDN controller to propagate those configurations across all of the forwarders in the form of flow tables. Later on, I'll be discussing this one in detail. Now, comparing traditional networking also to SDN, control is then centralized via the SDN controller. For traditional networking, configuration and resource provisioning is done independently across devices. This is what I mentioned a while ago, that if, say, for instance, you encounter or you forgot to configure the given protocol on one of the devices, and you try to test now packet forwarding, you try to ping one device from the other one, and then you get an error. So this is usually the case is because you have to go into the CLI of that device first, configure it first, log out, and then go back again to the other device, configure that device, and then log back out again. So there's a bit of a hassle also because you're trying to configure several devices at any given time. And of course, because of that, the risk of having misconfiguration or lack thereof is higher, kasi you have different means of, different interfaces to interact on. Okay? So another one, comparing traditional networking versus SDN, security is implemented independently across the different devices. No? Unlike in your SDN, it is normally centralized. Now, the fourth point here no, is a bit of a misnomer. This also has a caveat here because security-wise, security implementation can be a double-edged sword, arguably. It's because, yes, you can, it might be better to have security centralized in the SDN controllers only, but it becomes more prone to an attack because once a vulnerability is identified in that controller and that is not properly enforced, then essentially the attacker can take control of the entire network just by gaining control on the controller alone, compared to, say, a traditional network wherein there are still some enforcements, or at least there's a certain level of isolation being done since the configuration is just limited to one device. Okay, so yung fourth one, no, medyo may konting caveat siya. It really depends on how SDN is being implemented, security perspective-wise. Okay?